All right, hey everybody. All right, sorry to interrupt you. I see a lot of people working away on list one. It's not a requirement that you finish like all the problems on list one. I'm just hoping that people can get like some of them. What I'd like to do is want to do another quick lecture section, and then I want to break out time for a nice long exercise at the end. You're welcome to keep working on the list problems if you want, but this last exercise, once we have file reading, then can begin to look like a real program, and it's going to sum up all the material we've talked about, lists and strings and all that stuff, put it all together, and that'll be the last thing for today. So the last data structure I want to show you is the hash table, or also called a dictionary. It's a very useful data structure. It's built into Python. It's pretty easy to use. So the delimiter character for a dictionary is the curly brace. So here I'll create one. I'll say d is equal to left curly brace, right curly brace. I'll just create an empty one. And the way the dictionary works, and I've got a little piece of art there from the handout at the top, is you can think of it as it's said to contain key value bindings. For each key, it can look up that value very quickly. So the way that works in Python is I'll say, under the key A, I would like to store the string alpha. And under the string O, I'm just going to make the same example I have in that little picture there. I'll store omega. And under the key G, I'll store gamma. If I did that right, hopefully. So what a hash table does is you always talk to it in terms of keys. You say, dictionary, please store this key, and it'll store whatever. And then later on, when you try and retrieve by key, this is the one thing that hash tables are fast at. It can retrieve by a key in constant time. It's just as fast as you can imagine. It's very quick at key retrieval. So for example, if I say, OK, dictionary, and now in Python, the way it works is we just use the square brackets. When I use the square bracket on the left, I was storing a value in. So that series of 3 assignments, that builds exactly this picture of the dictionary. So you can think of the dictionary as, well, it has a set of keys, and for each key, it points to some value. If I want to do a lookup, I would say, well, instead of just don't put it on the left-hand side of an equal. So if I just say d of a, it just returns the value, alpha. Now, not to belabor the point too much, that's the one thing that dictionaries are fast at. You could put 10 million keys in this dictionary, and yet for a particular one, you could call it up, and it would call it up in just a few cycles on the machine. It's very, very fast at key lookup. That's the one thing that it does. So let me show you how, a few more features you can do with dictionary. So obviously, you can store stuff in. You can use the square bracket to get stuff out. If I refer to a key that is not in there, I say, all right, dictionary, what do you have for key value x? What I get is actually an error, a key error. So that's a little unpleasant. I think Python is trying to be sort of consistent with the list here, that if I said list square bracket like 1,000, and there is no 1,000, it would have given an error. So I think there's sort of an attempt to be kind of consistent with what square bracket means. And square bracket means, yeah, it should have been there. And if you refer to something that's not there, it's an error. Fortunately, there's an alternative. There's a .get method on the dictionary. And so if you do .get, in the simplest form, what it does is it returns the value none if it's not in there, and otherwise it returns the value. So if I say .get of a, then I get alpha, but of x, then I just get back nothing. It happens in the interpreter. None is sort of a special case. It just prints nothing and just comes back. So if you want to distinguish, if you care whether or not thing is in there, then you could use get, and you're more protected. How do you suppose you test if a value is in a dictionary? Someone say? Something I wrote, I think, over there. Yeah. All right. What I'm looking for is in. Right? Dictionary is just another composite thing, just like a list. So I could just say a in the dictionary. It's like, yeah, it is. Or I could say, well, is x in there? No, it's not. So again, kind of live a little higher on the food chain. Just use those built-ins. I'm going to. Well, here I'll show you some more features first. So the dictionary as itself it's just good at this sort of key value storage. That's all it does. One thing that's kind of common is you open a file and you read a bunch of data. You store it all in a dictionary to kind of organize it. And then once you're done with it, you want to loop over the dictionary and kind of look at all the contents. So the simplest way to do that is the dictionary has a method called .keys. And what that does is it returns a list of just the keys. There's also a list of, and notice the keys are in kind of random order. Now, in this case, I guess they appear to be in alphabetical order, but as the dictionary gets bigger and bigger, these will be in kind of a random order. This is the hashing strategy that the dictionary uses causes the keys to be in a scrambled order. I'm sure I'm probably switching between the word dictionary and the word hash table. So, yeah, those refer to the same thing. And hashing is this general strategy that's very powerful. You'll see it crop up in a lot of languages. Likewise, there is a dot values. Oops, what's the problem there? Oop, I spelled it wrong. So this just pulls out the linear list of values. And it's in a kind of a random order, but it's in the same random order that the dot keys was. So I'm going to show you what I would regard as kind of the most common case of looping over a dictionary. You've built the dictionary. It's got all this, social security numbers or URLs or whatever in it. And now you want to loop over and look at them. I would write it this way. I'd say, well, for k in dictionary.keys. All right, so what that means is go to the dictionary, pull out the linear list of keys, and now I want to loop over that. But as just sort of as a nicety, the keys are going to come out in kind of random order. So let's loop over the sorted of that. Pull out the keys, sort them, now loop over them. I'm going to write this all in one line. I'm going to say, like, well, what I could print is, let's say I want to print a little thing with like an arrow, like this key goes to this value. I could say print, first of all, the dictionary, square bracket k. So just that's the, I'm sorry, do it the other way. I'll do it this. I'll say key colon, comma, k. And then I'll say comma, and I'll draw like a little arrow. And then I'll say dictionary square bracket k. So if I run that, without too many errors. So that's going to pull out the keys. It's going to loop through all the keys. And then for each one, it's doing this little line of like, here's what the key is. And here's the value that is stored for that key. So that is the most, I think dot keys and dot values are the most common case. There is this one other case, which is called dot items. And what dot items does is rather than just pulling out the key or just pulling out the value, it pulls them both out simultaneously. And it puts each one in a tuple size 2. So what you're seeing here is a list of tuples. Each tuple is length 2. And each tuple represents one, what I would call a binding from the dictionary. And so what you could do is you could, if you really want to just get the key and value all in one step, then you could use dot items. So for example, I could say for tuple in d dot items colon, print the tuple or whatever. Oops. Oh, right. Check it out. I left off the parens here. So that's another way of kind of dealing with all of the data of the dictionary once you've built it up. Okay, I think that's, I'm not going to show you that other thing. This is messy enough. So now I'm going to sort of step outside for a second. I mean, what is the dictionary good for? Suppose you've got an Apache log file of like 20 million GET requests. And in a sense, the Apache log file, it's just random, right? This IP address requests something, and then this one, and then that one, whatever. It's all just kind of jumbled together. A very common form of the use of the dictionary in solving a problem is that it takes incoherent data and it makes it coherent. It organizes it. So for example, suppose I wanted to count how many times each IP address had been hitting my server by looking at this log file. What I could do is I'd say, OK, I'm going to rip through the entire file, which I'll show you in a second. And for each IP address, I'm going to use the IP address as, let's say, the key in the dictionary. And as the value, I'm just going to count how many times I've seen that key. So the first time it shows up, I'm going to put a 1 in there. Maybe I could use in to kind of check if it's there or not, to kind of bootstrap this like the first time I put it in. And then the next time I see that IP address, I could go to the dictionary, use square bracket, I'd say, oh, is this in there? If it is, I'll do plus equals 1 or something to kind of like bump the value up. And so by the end, I've gone through this unordered data, and I've used the dictionary to kind of associate by IP address. So anything where you've got this random piece of data in one place, and you want to associate it with other occurrences of that random piece of data, the dictionary is like hands down the good way to do that. And it relies on this fact that it's very fast at this one operation, which is given any random key, it can look up that value very, very quickly. Now, stepping even farther outside of myself, Google really runs as a big hash table. And that's basically what it is, right? It's a big hash table by word, right? And each word kind of points to a list of URLs or scores or something. So as a user, when you type in a word, whatever, Britney Spears, That's 2 words, I guess. Really, it's going to this gigantic hash table that is Google. It's looking up Brittany, and there's this big list of URLs, and it's looking up Spears, and it does those efficiently, and then just kind of intersect those lists. I mean, that's Google in a nutshell. I'm sure that was very clarifying. All right.
I'm going to Yahoo now.
All right. Yeah, no, Yahoo. It's a linear list. Anyway, yeah, they also have hash table technology, so that's not the problem. All right. So yeah, predictably. The big exercise for today, which I'll demo in a second, I'm going to want you to use the dictionary. That's a totally appropriate thing. And in fact, dictionaries are, you can sort of see, the subtext I'm telling you is dictionaries are an extremely useful and powerful construct. And so I'm going to want to push you to use them. It's a good thing to get practice with. All right. So let me show you last thing, which is files. And I think I'm going to go back to editing hello.py for this. I'm going to show you some file stuff here. All right, so here's hello. Right, so this is just I'm gonna. In Unix there's this utility cat, and what it does is it just prints out the contents of a file. So I'm just going to go ahead and kind of recreate cat in Python just to kind of show you how to open files. So let's say this thing takes a file name argument. I'm going to write a function called cat, and it takes a file name argument. And what I want it to do is just print the contents of that file out. So the way to do this is there's a built-in called open. And its first argument is a file name. And the second argument to this kind of resembles other languages. I can specify an R here to mean, oh, I want to open this for reading. Or I could specify a W to mean I want to open it for writing or whatever. In this case, we'll open this for reading. And there's actually a variant. If you put an RU there, it opens it in a way where it'll ignore DOS line endings versus Unix line endings or whatever. It'll kind of fix that under the hood. So that's nice. So probably the simplest way to deal with, let's say there's a text file, to deal with all the lines in a file is you can actually write a for loop over a file, sort of like it was a list. So I can say for line in F. So I loop over F, and what is great, what it does is it actually reads the file in line by line and just processes one line at a time. So if I were to say print line, all right, this is why I want to just echo the file. So I'll just print each line, and then here I'll fix up my main to call this thing. So main just takes whatever command line argument I have here, and it's just going to call cat and just say print this out. So I'm here, right? OK, so let's see. In day 1, sorry, I've got this file small.txt. I'm going to take that up here. OK, so if we look at what's in small.txt, it's this beautiful poem I wrote for the class. Blah, blah, blah. All right, so now if I say hello.py of small.txt, what it's doing is so I open that file, it's reading it, and it's printing it, but I'm getting this kind of line doubling, not improving my poem. So the problem is this line string, it includes the new line at the end. And then when I print it, I'm kind of putting another new line there. So to fix this, there's a Python obscure syntax. If there's a trailing comma at the end, that inhibits that last new line. So I'll save that. I'll just run it again. Ah, excellent. OK. All right, so that is one way to read a file. You open it into this thing F, which is kind of a file handle kind of thing, and then you just loop over it. This technique, where you loop over line by line, it has this one virtue. Sort of going back to my Apache. I could have an Apache log that's like 47 gigabytes of just text, and this loop will run through it, but it will not require 47 gigabytes of RAM. This uses a tiny bit of RAM because it deals with each line independently, and that's an efficient case. So if you can go line by line, this is the efficient way to do it. Also, just for completeness, at the end there's a .close. Probably should have done it, close the file handle, just to be polite. If you omit it, it closes it when the process exits, but probably more correct to close it. All right, so that's one way of doing it. I'm going to make an aside here, just a stylistic aside that you're going to need badly in about 20 minutes, which is if we were in Java or C++, we would know what variables are strings and what variables are lists because there's all this declarative syntax telling you what's a string, what's a list, or whatever. I want to point out, in Python, there would be all these queues. sort of, when you look at your own code, there'd be all these cues about what's going on. In Python, there are no cues. You just have to keep in your head, what's a file name, what's a file, what's a string, what's a list. Now, there's something you can do about this. The one thing you can do, the one thing you get in Python is your variable names. And you knew, you were taught or whatever, you knew, oh yeah, having good variable names is kind of a good idea. But in Python, it's 10 times more important. So I want to point out in my little garbagey example here, now when I'm typing stuff in the interpreter, a lot of times I use one variable names, but I'm a little more disciplined here in the editor. This thing, I spelled out, yeah, that's a file name. Not a file, not a list of strings, file name. It's very useful in Python that you name the variables to kind of keep track of what is that. And very often when I'm walking around standing behind people, many of the bugs I see is where you're kind of off by one. You've sort of lost the scent. You're like, oh, this, that's the file name. Oh no, it turns out that's a line from the file, or it's a list of all the file names. You kind of get this off by one of like, wait, what does that variable contain? Because you've got this natural progression of file name to file to line of text to word or whatever. It's very easy to get off by one of where you are in that progression. And Python, the only thing you have is the variable names. So I've worked with a lot of people, debugging basic Python programs, and I'll tell you, it pays off very well to be conscious of giving your variables good names of like, what is that? Is that a string? Is that a list? Is it a dictionary? Whatever. And certainly in my solutions, whatever, I've followed that. I mean, it's just good style anyway. But in Python, it happens to pay off especially well because you've got so little else going on. All right. So on our bigger exercise today, this will certainly come up. The other way that this comes up is whenever I have a list of things, I will try and give it a variable name ending in S, words or lines or something like that to sort of cue me like, oh right, that's the list of things. OK. End of editorial. It's actually good advice. So my second favorite Python file primitive is there's this function, I think, the capitalization I remember, I think it's read lines like that. I guess we could just try it. And what that does is it reads the entire file into memory as a Python list of lines, where each element in the list is one line from the file. So then here, so for cat, I could just say print lines, I guess, and it'd just be done. All right, I'll try this to just check if I have the naming right there. Has no attribute read lines. OK, apparently not. Maybe it's lowercase l. It must be. Oh, excellent. All right, so now you can see, so now it's a Python list. So now you could loop over that list to do something or whatever. So if you had a file with like, 10,000 something or others, and you wanted to process as a list, this is one easy way. You can just pull it into RAM in one step. Notice if the thing is 28 gigs of data, now this does take at least 28 gigs of RAM to store. Like I really am just storing the whole thing in RAM. But on the other hand, I get very convenient access to it. My absolute favorite, I know you've been very curious, what is my favorite Python file primitive? Oops. And it's just, there's this one just called read. And what it does is it reads the entire file into one string. And I know that's it, but for some problems, that is just so convenient. There's no notion of like looping this line versus that line. I just, like, suppose you wanted to do some big search replace operation on a file, or say some regular expression processing. Yeah, just having the entire thing as like one big string is phenomenally convenient. So that is, I think that'll just work. Oh yeah, check it out. So we'll build on that one a little bit more later on. I think for today, just the first one I showed you, just for line in F, is probably the most common one. Also, going back to my my ranting editorial about variables, notice when I read into a variable called text, like I'm trying to remind myself, like, oh right, that that's the whole text or whatever. Alrighty, so we've got dictionaries, we've got files. These are the last two elements that you needed to now write. This is kind of an inflection point where, like, with all the stuff I've showed you now, you can write just like real Python programs. And so that's what our last exercise is going to look like. I already gave you the advice about variable names. One other piece of advice I should give you. I'm about to demo some larger programs for you that I want you to implement. And it is sometimes, or at Stanford, right, if I'm talking to some 17-year-old, what they will do is they'll type in the entire program. Like, well, here's my vision of how the entire program is going to work. And then once they've typed the entire thing in, then they try running it. And it, like, of course, it crashes on like line 2 or whatever. All right? That is not the way to do it, especially not in Python. Python is so good at you make a little change and then you can run. And you can see immediately kind of what's going on. So you want to sort of keep that focus right at the kind of growing edge of your code. And there's two things that are going to help you out here. Let's say, so for your next problem, you're going to do these things that involve like reading a file, then processing the lines. And for each line, you're going to want to kind of do something. What you should do is move very incrementally. Like, we'll read in the lines, and well, the first thing, I just want to print each line. So you just print each one, and then after you've printed, when you're done, you could call like sys.exit or something, just like, OK, we'll just bail out. And just get that working to where like, oh, now it's printing the lines. So you'd say, OK, well, what's my next goal? All right, my next goal is, I want to find all the words. So I'll just print each word or whatever. And so just have the program print what your kind of next goal is and keep iterating it until it's printing the right thing. And because Python is very easy to edit, and its built-in printing facility is actually quite good, right? You can print a dictionary, you can print a list, all that stuff. There's no code in your code required. It just prints. It'll dump something kind of reasonable to the console, and so you can use that to kind of iterate very tightly. And certainly, as I walk around answering questions, this is the same thing I'll do. So that's my way. Have a goal, print what you have. Last thing I'll say about it, it's kind of nice if you print what your data structure has, kind of as step n of solving this thing, seeing the pixels of like, oh, I have a list of strings or whatever, can help your imagination think of like, oh, OK, well, what's my next step? Oh, now I need to make a list, a dictionary or something. And so it's nice to be able to just see your data structure right there. And I guess more broadly, why is it the Python programmers get in this zone of like, wow, they're very productive, they can get stuff quickly? It's partially because not just that they know the Python language, but that they're programming it in a style that fits the things Python is good at. So this is the right style for today. OK, enough kind of hand-wavy advice. Let's talk about actual work. OK, so I'm going to go back down to the day one directory. And I'm going to show you two programs. All right. As before, these programs, so the first one I'm going to show you is word count. It's the first exercise for today. This is the one I want you to do today. And I'm going to demonstrate very quickly a second exercise, which you could do if you just felt like you wanted more practice or whatever. But word count's the one I want everyone to work on. So I'm going to go down to my solution directory so I can actually demo it working. So what word count does is if you, oops, ignore that hey there thing. That's left over for something else. So what it does is you give it a file. And what I want you to do, I'll just run it here. And I'll run it on that small file. Oops, I'm sorry. It takes a command line argument, in this case, --count. And what this does is I want you to go through the file. I want you to find all the words. And I want you to just count. And I want you to convert them to lowercase. So we won't count uppercase and lowercase different. I want you to just count how many times each one appears. Now, to find the words, there's this Python built-in, which I showed you before. Here, I'll show you again. So if I have like AAA, BBB, CCC, there's .split. And I showed you .split before with like a colon or something. It turns out if you call .split with no arguments, then it splits on white space. And that's going to turn out to be a pretty reasonable behavior for this program. So for word count, I'm just looking for split with no arguments. So you just get the words, and it just automatic. It knows what a tab is, what a new line is. It'll do something kind of reasonable. Tomorrow with regular expressions, we'll do a better job. But for today, this is sufficient. All right. So what I want you to do is process the whole file and like figure out what the words are. And then you can debug on small.txt. And then it's a little more fun. Then we also just have the entire text of Alice in Wonderland. And so you can just process that as well. Something a little dopey is happening here where like the word while appears 20 times, but the word while followed by a comma appears 4 times. This is just because of the split strategy is just on white space, and it's not smart enough to trim off anything else. OK, I apologize. This is just to get us through today. Tomorrow, I will show you how to deal with the punctuation as well. But for today, I think we've got enough other problems just with the dictionary. Really, I want you to learn the dictionary in the file. So one of the things that's neat about this is Python is not known for being especially fast. It's known for being quick with your time. As a programmer, it's a great instrument, and you can get stuff done very quickly. But memory, algorithms, whatever, it's just not that quick. That's just you should know. That's one of the things to know about Trevor. And yet, I just processed the entire Alice in Wonderland, and like whatever. If you time this, it's like about 1/20 of a second. And this code is just written in the most obvious, convenient way, the laziest way I could think of, which is, of course, the way all my code looks. So on the one hand, Python's not the quickest language. On the other hand, most things are just kind of I/O bound. like probably saving that last nanosecond of CPU time is maybe not the best use of your time, where you want stuff to work. So that'll certainly show up here. All right, so that is part A, counting the words. Then, and I should mention, the parsing of the command line arguments and the other kind of boilerplate, I provide for you. So when you look in that word count file, you'll see there's some boilerplate that's done for you, and then you figure out what just the part you need to add. So then I want to have top count. Oops, let's do top count on Alice in Wonderland. Do you guys have a 20th of a second to spare? Sure. All right. All right, so what does that do? Yeah, it's by the frequency. Yeah, so what appeared most often. Now, just in terms of writing code, well, these both use a dictionary which has the word as the key and the count as the value. I don't want to have one copy of the code that builds that dictionary for dash dash count and another copy of the code that builds it for dash dash top count. Really, you should have one copy of the code that builds the dictionary, either by putting it in a separate function, or you can look at my solution, or whatever. But I want one copy of that code that builds the dictionary, and then we have these two uses of the dictionary. Either you could loop through the dictionary and just print all the words in alphabetical order, or you could go through the dictionary, and it's a little trickier. It's like, oh, I don't want all the words. I want to pick out the words that have the big counts, and I want to print those, and in sorted order by count. So for that problem, you kind of want to use the dot items on the dictionary, where you can pull out all those tuples. And then maybe there's some custom sorting, right, where you want to sort the tuples now with the big second number. Anyway, that's part B. So the first problem is part A. All right, I have one more thing to show you. This is a whole other program, the Mimic program. And I'll just run this on Alice in Wonderland. Let's see, what does this say? Alice's shoulder and birds with some minutes. The only grinned a stop to death, quote. You might do something splashing about at the caterpillar. What is this?
It's like that business speak program.
Oh, yeah, you could. Well, so actually you can run this. Sorry, so I'll tell you what this program does. It's a fun program. It uses, actually, in terms of coding technique, it's very similar to word count. Same level of abstraction. It just does something different. What this program does, and also it shows how Python is actually quite fast in some sense. It looks at every word that appears in the text. And for every word, it just keeps a Python list of all the words that ever appear after it in the entire text. You can sort of imagine building a Python dictionary that just sort of tracks this. So for the word sister, I have a list of all 7 words that ever appeared after the word sister in the text. So then once you have that data structure, you could just pick a random word. So I'm just going to start with Alice's. And I look at the list of the words that ever appeared after that, and I just pick one at random. So apparently in this case, I got shoulder, comma. And then for shoulder, comma, I look at the words that ever appeared after that, and it's just totally random. And yet, it's sort of weird. I mean, it's not completely believable, but it's sort of weird for what an unbelievably primitive strategy this is. You can end up mimicking some text. So you can have fun if you run it on Google Design Docs. The other thing that you can do, this is only a computer scientist would probably, is you can run it on Python text. And it's sort of like, in some random sense, like my variables and comments and stuff. Right? I mean, the line breaks are completely messed up. But so if you have time or extra energy to kill, you could take a look at the Mimic program. But really, what I want people to work on is the word count program. And that is the last thing for today. So please go ahead, get started on that. If you want to keep working on the list ones or the earlier ones, I'm happy to answer questions about that. But this is a nice kind of a threshold of like, oh, now this is really all the pieces of a real Python program we put together. So it's a nice exercise to work on.